Okay, now let's talk about how we can change permissions on files. Say I write a script here, vi script sh. It runs with bin bash and it says, hello there. Very nice script. Ow, I don't have a write access. Where am I? I'm inside home. Why I do not have an write access? Because on the home directory, this is the access. It's a directory. Root users can do whatever he wants. Root group members can read and enter it. Others, which is me, can read and enter it. They cannot write there. So when I try to VI something here, it says you don't have access. Cool. I will run a cd. Now I'm in inside of my own home, which I have write access. I say script sh. Write and script. Okay, I will try to run this. It doesn't run. It says permission denied. This is not an executable. You cannot run it like this. This is how we run our scripts inside our own home. Permission denied. Because why? ls-l. Why? It didn't run. Because Jody has read and write. People who are member of a Jody group, they do have read and write, no execute, and others only have read. So no one can execute it. I have to add execution bit to this. To do so, you have two different methods. Using octal or base 8 codes, or use shortcodes. We will start with octal. In the octal method, you have 3 different accesses. 1 for execute, 2 for write, and 4 for read. So if you want to give read, write, and execute, you just add these to each other. That would be 7. 7, 7. It means if you grant this access to a file, it means the user who owns the files can execute, write, and read. Members can execute, write, and read. Others can execute, write, and read. This is too much. Most of the case, we go with 775, which means the owner of the files have everything. 4 plus 2 plus 1, which is execute, which is write, which is read. Others have everything the same. Group members have everything which is the same. And others only have 4 plus 1. Execute and read. So others cannot write on my script. Let's try this. I will say chmod, change mode, 755 script. 755. 775. 755 is better. Whatever. /l script. Now, I myself can write on it. Others can only read and execute. Now, if I try the script, it runs because it has execute permission. This is how you grant or change accesses using the octal codes. There is one famous switch, -r, which recursively does the same thing to all the files and directories inside where you ordered. For example, if I do chmod 600, this means 4 plus 2. So read and write only for the owner. For the group members, 0, so nothing. For others, 0 for nothing. If I run this on the /temp, it says changing permission of temp operation not permitted. I'm changing the permission of the directory itself. Okay, this is not permitted. I agree. If I say -r, I said inside temp whatever there is. It says, okay, most of them are not permitted because these are not my files. This belongs to other people or even root. But some of them were my files and are changed. cd temp lsltrh. For example, funny file was mine and it's changed like this. So you cannot change other people's files permissions. Very logical. 1 and 2 also were mine and they are changed as I told. But this is super dangerous. This happens all the time, especially for novice admins. They are installing, for example, a web server. The files go into var, www, html, whatever, and it's not working. Web server argues that I do not have access here, and they just change to 777 all the files here recursively, and everything works. Good, because now web server do have access and everything works, and they leave and happily ever after. No, it's not a good story, because someone else will buy an account on the same server and they just go here and they can change your files, and suddenly you are surprised. How can they deface my website? Because you gave them access to your files. So don't change any permission if you don't know what you are doing. Learn first and then do. Especially with -r. If you do something like chmod sudo chmod 777 on / your Linux is broken. It's your machine, you can break it. Do these tests, it's fun. So this is how octal base works. To summarize it, 1 is for execute, 2 is for write, and 4 is for read. Add these to each other and create whatever you want. If you only need to give, for example, write to yourself, say 2. For your group members, you only need write, and no one else should be able to do anything. This is idiotic, because no one gives write without read. So, there are some famous ones. 775 for executables. 600, you can read and write, no one else can do anything. These are the general ones. But you can combine whatever you want from adding those numbers to each other. But as you saw, this is kind of difficult if you want to do more complex things. So we have some funnier methods. For example, this funny file do have only read and write. I want to add execute for the group members. What is the code? So we'll go with chmod group members plus execute on funny file. Easy peasy. Or you can say others plus read and write. Others got the read and write access. Or you want to say chmod user equals read and write and execute, group only read and write, others nothing. This is a very easy method to configure. So some people love this because they easily can do whatever they want, and you saw it. We did a couple of things. Group equals read and write, so it equals read and write. I could say chmod group plus execute on funny file. Just add this, don't touch anything else. Or I can even say group minus x and others plus read. We remove the execute from group and added read to others. These three. This is a very, very easy method. And also, again, you can do -r and do whatever you want. This is how you can change permissions on one specific file. But how can we change the ownership? Say I have a file here. I touched a file. My file, it's here with this access. I want to change the ownership to someone else. For example, I want to change it to admin. For that, you have change own, chown, change the ownership. The user should be Jadi, the group will be admin. I've changed the chown, user, colon, admin. Is it called colon? I think so. Jadi and admin, the user and the group. Which file? Again, you can use -r to do it recursively. Let's see if I can change this to root. I cannot change the ownership to, so I become root. I say change ownership, for example, of this file. It belongs to CD-ROM, so I will give the ownership to Jadi funny file. I change the ownership. You can do whatever you want with the files. So change the ownership, give it to someone else, and for sure you should logically have access. So I cannot take over someone else's file. I should use with sudo and become root. Again, you have -r. And if you only need to change the group, you can do with chgroup. So I can do a chgroup to admin funny file. I change the ownership to admin. And this is the idea behind how the security in the Linux world works. As you saw, every file has a user and has a group, for example, admin. You can add users to as many groups as you want. So you can create a directory as a shared directory, call it shared, give it the right access, read and write and execute, because people need to enter that. On this, to the group members, change its ownership to the, for example, shared group, and add people to the shared group. I told very bad. You can create a shared directory, then chown, or as we know the exact commands, change group to the shared on shared. You have to already have this group. So in many cases, people create a new user called shared. So the distro will create a group which is called shared, and you change the ownership of this directory to this specific group. Then you add people to the shared, and you also do a chmod group plus read, write, and execute on shared. So this directory will have this access for its group members. So whoever is part of this group can write in this directory. How to add users? You can say user mode -ag add group. For example, sudo to Jadi. Now Jadi will be a member of the sudo and can run sudo the next time he logs in. This is how you add a user to a group. And at the end, something which I can mention is, as you saw in groups, shows me what groups I'm a member of. ID shows me my primary group here and all my groups here. So if I create a file now, the group will be my primary group. If you want to change this, you have to, I think, yes, new group. And say, okay, I want to have a new default group. And for example, LXD is my new default group. If now I use the ID, you will see that I'm still Jadi, but my default group now is LXD. I'm still part of all these groups and I can change my default group. So if I do a touch new file's default group will be LXD. I have never seen this out of the LPIC. But a couple of super fun points now and how hackers keep their access going on your system after they became root for once. Access mode. I showed you etc passwd, where your user is stored, right? If I do a ls-l, you will see that you do not have write access here. So what happens if I want to change my default shell? Or more than that, etc shadow, where my passwords are kept. This is where my passwords are kept, and I cannot even view it. Only root has read and write. Our root group has only read. Others do not have anything. So how can I change my password with passwd command? Practically, it needs to be able to edit this file, right? And I don't have access. So what happens? This is a nice trick. I can say which passwd, where passwd is, and then say, let's have a look to the passwd. First things first, its color is red, so it wants your attention. Something is different here. Can you spot it? Read, write, and S. We are used to seeing an X here for executable, but now there is an S here. S is for suid. It's a fun idea behind managing these accesses. Normally when I run a program and I'm Jody, if I have access to run blah blah program will be running with my access. So if it needs to change one file, it checks if Jody do have access. If not, if Jody's groups do have access. If not, if others do have access. But it will run with Jody's access. When this bit is set, instead of X, you have a S. So for example, some day we have done some ch mode, user plus S, user being passwd, and that's why it's showing it in red, so it will catch your eyes that this is something very special. When this is set, instead of X, you have an S here with this, for example. When the file is runs, it runs with the user's access. Practically, it looks like that root is running this. So it has access to edit shadows. Once more. When you have an S instead of X, suid, set user ID is set. So Linux runs this program with the access of its owner, not with the access of its runner. This is super cool. We have the same thing for groups. You can have an suid or guid, set group ID. And here you have one S, which tells you that this program will, when running, will have the access of its user, the owner, and not the user who is running it. You can check this with plus S and minus S instead of X. How hackers use it? As soon as you are inside the system with the root access, for example, say, bad admin was working something and just left the computer without locking it or logging out, and you are sitting behind the computer with the root access. You just copy something like a VI to my VI. Chown it to the root. So root owns it, and change its access to user suid. Your my VI. Now, whoever runs this my VI, the my VI will be running with the root access. So you can edit any file on the system you want from now on, as long as this is here. Or even you can copy and bash your shell and give it the as ownership of the root and suid. And whenever you run this specific bash on your system, you are root because you are running it with the root access. This is a super cool method. Use with care. And there is one more bit which is called sticky bit. It is shown with this T at the end instead of the X. When you have a sticky bit set for others, people cannot remove or RM or delete your file. This is cool because normally, for example, on the temp directory, different people do have lots of files and they may have access for others to write on them and you don't want them to delete it. So if you set the T instead of the execute, only the owner of the file is able to delete it. If you want to do this with the octal, it's like this. For suid, it's 4000. For guid, it's 2000. And for sticky, it is 1000. Play with them. This is super fun. And the last thing is another fun question. I create a new file. Let's go to temp. There is a my file here. Cat new file. Cat silly. Okay, we don't have a silly file. I will touch silly. So this is created. I will check it. This is its default access. Where does this come from? How the system knows what the access or permissions should be when I create a new file. These two we know. This is my user. This is my main group, which I changed to this. But what is this? How this is decided? This is decided with a concept which is umask and also a command. This confuses many people. I don't know why. It is super easy. You have a umask in your system. Normally, on many distros, umask is 2. Whenever you create a new file, system takes 666, subtracts your umask from it, and this will become your permission. So, at the moment, 666 minus 0002 or 002, no difference, that will be 664. So, this is 4 plus 2, which is read and write. This is 4 plus 2, which is read and write. This is only 4, which is read. So the access is 664. Read write for the user, for the owner. Read and write for the group members. And only read for the others. So whatever umask you have, you subtract 666, subtract from umask, vice versa, I believe. 666 minus umask, and this will be your default permission here. You can also change your umask. For example, I say my umask is 066. So if I create a new file, 666 minus 066 will be 600. Read and write, nothing. So if I create a new file, touch umask file and ls-l umask file, it will be read write, nothing. Super easy. I don't know why this confuses people. Also, you can do the same with umask. You can say umask others plus read. Now this is your umask. Whatever, if you don't want to calculate them manually. Now if you touch a new file and ls-l new file for me, others will have a read because I told umask to do this. On some systems, umask is 0002, so all the files will have access like this. On more secured systems, the umask is 66. So whatever file you create, only and only the own user will have read and write, and nothing else for others. This was the last thing you should know about this. You can try it with like this. So umask user RW, G nothing, O nothing, group nothing, others nothing. Or you can say umask group plus R to give read. And always say 666 subtract from umask will be the permission of your new file. Hope you enjoyed it. It's very important. Never ever do -R777. It does not solve your problem. It solves hackers' problem to enter your system. Have fun. This was Jati. Tell your friends if this was fun.